Hello, everybody. Good morning and welcome to this sixth webinar in our Advanced Air Mobility series. I see some folks are still trickling in here, but I'm going to get us started anyway, just for the sake of time. If you if you are on our email list, you should have received an email last week about a little change in our lineup here. Our presenters that were previously scheduled for today were unable to attend today, so we have swapped some things around. So thank you for your understanding, and also thank you to today's presenter, Nick, for making himself available to be with us this morning. Before we get started, I'd like to say that this webinar series is sponsored by MnDOT's Office of Aeronautics and is administered by the Airport Technical Assistance Program at the University of Minnesota's Center for Transportation Studies. This webinar will be recorded and, like all of the other ones, will be available to view and to watch later on our website, airtap.umn.edu. Here on the screen in front of me are the rest of the dates for this series in 2025. This information can also be found on our website. If this is your first time joining us for one of these webinars, here are some logistics. At the bottom of your Zoom screen, both the chat and the Q&A features are turned on. On the left side is the chat. That's where you can speak to anybody else who is in the audience. You can share ideas with them. You can let us, the panelists, know if there are any difficulties, if you need any technical assistance. And then on the right side of the screen is the Q&A. I will be monitoring the Q&A throughout the whole webinar. When time allows, I will be asking your questions to our presenter, who is Dr. Nick Wilson from the University of North Dakota. So again, Nick, thank you for joining us. I have a brief bio for Nick that I'll share quickly before we get started. Dr. Nicholas Wilson completed his PhD in Educational Foundations and Research from the University of North Dakota in May 2021. Nick worked in the aviation and aerospace industry for several years prior to returning to UND as a faculty member in 2014. Dr. Wilson holds a patent in haptic cueing in an aviation headset application and has published numerous collaborative papers on pilot fatigue, workload, motivation, and most recently in the sustainable aviation domain. Dr. Wilson has presented research for several years at the World Aviation Training Summit, the University Aviation Association Fall Meeting, and most recently at Transportation Research Board Annual Meeting. Dr. Wilson grew up in northern Minnesota and is an active pilot and aviation instructor. So, Nick, take it away, please.
Jackson, thank you for that wonderful introduction, and I'm very glad to be here presenting. Obviously, as Jackson mentioned, this is my home state, potentially the audience members, at least some, I assume, and there may be some broader audience as well. So I am glad to present our research on electric aircraft. I'm going to share my screen now, so if anyone was wondering if this is just going to be me talking in my office, no, I should have some visual aids for the audience. So maybe a thumbs up if we in fact can see. I assume we can see, and we'll go from here. So as Jackson mentioned, we are going to be talking about research in electric powered aircraft. And we've done some studies here at the University of North Dakota on feasibility, and then we've done some stakeholder based studies, and that's what we're going to look at today. So we have a part one and a part two. Part one is really looking at the question of if we adopted electric powered aircraft into our flight operation as a general aviation training provider. Obviously, we're a Part 141 collegiate aviation training program, so somewhat more structured potentially than Part 61 at a smaller airport. But if we adopted this into our training curriculum, what would that look like? And that's sort of question one. Part two is looking at the questions related to our attitudes, and what in fact needs to occur with respect to price differences and what are our attitudes related to leaded aviation fuel and sort of how does that influence our willingness to change to potentially more sustainable options. So that's how we're going to break down this discussion, and we will pause at the midway point between part one and part two. So then we'll have opportunity for questions if there are any. So I'm going to start here. This might look like Gatorade or something more benign, but this is our well-known friend in the GA community, and I say friend in quotes, but 100 low lead. 100 low lead's been powering aircraft for quite some time. And I'm a part owner in a small aircraft, and we need 100 low lead currently to fly our aircraft. So that is something it's facilitating our training needs, and it is performing a needed role in general aviation currently. The downside, as is growing in awareness, is that the leaded part of 100 low lead is a neurotoxin, right? And so, because of the tetraethyl lead composition, even though it's a small composition from a volumetric level, it is a composition of lead that it's not good for the environment or the people in the environment. And so this is not the driver of change, but it is one motivator of why we're having these discussions because no one should want lead in their environment. It just is not good for any of us. So I bring this up as sort of an imagery to think about as we're talking about some better options, potentially better options for aviation going forward. And we can kind of move through here, well introduced by Jackson Piper. But yes, I am been at University of North Dakota now approaching 11 years and regularly speak on this topic and others related to aviation. So there it is. UND, if we have members of the webinar who are not from the Minnesota, North Dakota area or Midwest, you may not know University of North Dakota is about a 1 hour flight northwest of Minneapolis, or about a 4.5 to 5 hour drive, depending on how quickly you drive. And then we're about 90 miles or so, 70 to 90 miles south of the Canadian border. So we're up there. We have cold winters and warm summers. So that's where we're at. We're a good training location to provide our graduates a variety of training experiences from wind to cold to warmth, all the in between. All right, so the fleet. University of North Dakota Fleet, we fly Piper Archers as the largest contingent of the fleet, which is the single engine trainer you see sort of most prominently in these photographs. So we also fly the Piper Seminole, which is a twin engine trainer. And in the center of the screen, you see the Robinson R-44 helicopters. And we also have a few aerobatic aircraft, the Decathlon, and there's somewhere in there, there's probably a Cessna, there's a single Cessna 172, and we usually have a Cessna 150 for some special purposes here and there. There's one King Air way in the back, if you see, so that's used for special training as well. So this is our fleet. We have around, let's see, it depends a little bit, but about 95 to 100-ish aircraft used for primary aviation training in the fleet. So a few numbers for us to think about when we're thinking about sustainable aviation and alternate options in electric aircraft and potentially drivers for change. 800,000 to 1 million. So that is about how much 100 low lead fuel we use in a calendar year. And so it depends on whether we include our satellite locations or not. So there's some nuance there in that number. But if you just look at UND, we're in Grand Forks, we're at least 800,000 gallons of 100 low lead. So that is something to think about. The other thing to think about is this number of 32,000. Okay, we did an approximate estimation. The amount of pounds of 100 low lead required for one of our collegiate aviation students to reach the industry minimum flight hours of 1,000. And that makes the assumption that they are, flying certain aircraft at certain times, giving them benefit of the fact that they are getting dual received or dual given, all of that sort of thing. So about 32,000 pounds of fuel needed for us for our graduates to get to those required numbers. So can we do better? So that's sort of the question. Let me go back a bit. Went too far. There we there we go. All right. So one of the questions are, can we do better? And the context I provided is showing us that, there are many companies who are working on electric aircraft. And the screen grabs that I've shown you there on the screen from left to right, this has been going on for some time. In fact, there's a gentleman at a recent webinar in Minnesota that had started working on converting an electric aircraft. It sounded like many decades ago, right? So this idea of alternate powering of aircraft is not necessarily a new idea, but it's been gaining a lot of momentum. And so one of those on the left is this Pipistrel Velis Electro. This is a two-seat light sport aircraft, which has EASA certification, and it has some recent changes to its certification in the US, or its ability to be used for training under an exemption. There are still some limitations there we're going to talk about. There's also been some attempts to convert existing airframes. So CAE and Piper were going to work on converting an electric aircraft. By Aerospace, it's kind of obscured there. By Aerospace is working on their electric E-Flyer 2 aircraft, and they're still working on that. So there's industry motion there. And then, we have some, this is a relatively recent article, May of 2024. There is a FBO training provider, I believe in California, that has 4 Pipistrel Velis Electros. And then on the right, I wanted to share this. Now, this is not a training aircraft, but this is from Aviation, I believe. Electric airplane Aviation lays off most of its staff. Now, Aviation is not in the training domain. They are not a primary aircraft trainer. But the point I was trying to make is that this process of development is nonlinear. There are advances and there are setbacks, and that's actually not abnormal when you look at how technology evolves. Very rarely does technology, have a perfectly linear path towards development, approval, and adoption in the environment. So I just bring that up as sort of a counterpoint, something to think about. So one of this first study that we did, that I'm going to get into the data now that we have some context, we wanted to ask this question, if we had a training aircraft, and let's say the training aircraft had anywhere between an hour of duration, which is around what the Velis Electro was. It's anywhere from 40 minutes to an hour based on some data I've reviewed. So if we had an hour of duration, and then if we had an hour and a half of duration of flight plus FAA reserves, how much of our fleet or how much of our flight lesson content would be able to be covered by this electric aircraft? So here's sort of our airspace. We used a data set from, I believe it would have been July of 2022 through end of June 2023. And so we had 52,700 plus training flights at UND during that time frame. And if you look at a good VFR day up in Grand Forks, our airspace is busy, and there's a lot of aircraft in and around the airspace. So we had a pretty large data set to draw from. At this time, all of them were powered by 100 low lead, and today, you may know this, all of them are also powered by 100 low lead, and there's another potentially separate webinar associated with that topic. So if we look at the distribution, this is a kind of a slide that you're welcome to use. It's also published in the Collegiate Aviation Review, and this is free download if you're interested. This is where a distribution of flights occur. So we have around the 1.0 hour mark is about, and we're going to get into this later, about 11% of our total flights And this is actually a cumulative flight. Every dot is represented. So if we add all those dots up, it's about 11%. Up here at an hour and a half of duration, not quite at the peak, that covers about 48% of our flying. I put a marker here. And so again, this is a representation of the Hobbs distribution of the invoiced lesson, just so that I didn't get ahead of myself here. So all of our 52,000 or 50, in this case, 51,000 flights included in this sample, this is what that distribution looks like. And right about at the tail end of this, this is the 2.0 hour mark. So if you can look at what we really need in our flight training environment is an aircraft of duration of at least 2 hours plus FAA reserve. Okay, so if we look at our mean of being 1.68 hours for flight hour duration, if we are in fact, looking at an aircraft that has an hour of duration or an hour and a half, it really wouldn't meet our current needs today without changes. Here's the same graph, but a little bit of a um, different view of the same information. And so from 0 to 1 hour of Hobbs meter length, and I might have said 11% on the previous slide, it's 12%. So about 12% of our training flights go from 0 to 1 hour. Okay, so if an aircraft can fly for an hour duration plus FAA reserve, it would only cover about 12% of the total flight lessons given our current flight operation. Now, if an aircraft can fly 1.5 hours of duration, okay, if we can fly 1.5 hours of duration plus FAA reserve, that's approaching a half of the total flights. So then if anyone's into curriculum design, you would say, well, that's not really the full story, is it? No, it is not. So here, let's take another level of analysis on this question. So then we started looking at it on a course by course basis, and we evaluated, well, how would an electric aircraft at the 60 minute or 90 minute, or also known as 1.0 or 1.5 Hobbs meter, how many of those flights would be covered? So if we look at the worst case scenario, we have almost 10,000, or actually over 10,000 flights in this sample or subsample. If we looked at, an aircraft that had less than 60 minutes of flight time, only about 8.5% of those flight lessons would be able to be covered. Then we have private. Let's take a look at that. If we had private air flight, or excuse me, private pilot curriculum, and we had an aircraft that had an hour and a half of duration plus minimums, about half of those flights could be used in the private pilot curriculum. So that's getting better. And then if we go to the instrument CFI, or also known as the CFII course for those in the field. So if we look at our CFII course, there's about 3,000 flights in that particular curriculum during that time frame. Almost 80% of those flights could be done using an aircraft, an electric aircraft, that had a duration of 90 minutes plus FAA reserve. So that's starting to look a little bit more promising. And that's kind of one of the outcomes we had was, well, maybe we wouldn't do it in early training curriculum, but maybe you do it in the double I course because of the sort of a better fit. A better idea is we're going to get to, and I'm going to get ahead of myself if I keep talking here, but is battery capacity. Let's get into that here. So here's another way to think about this. If we were to take the previous information from the table I just provided on battery duration of this hypothetical electric aircraft, and we look at it at a curriculum level, you might have lessons that look like this. If we assume this is a linear progression of flight lessons, maybe the first lesson is a short lesson and you can fly with an electric aircraft. Maybe lesson 2 is sort of unclear, and maybe it's a little bit too long to use for an electric aircraft, so maybe you have to fly a piston-driven aircraft powered by some form of an avgas. Okay, so you can kind of get the sense that you might be switching back and forth between a traditional piston-driven engine and an electric aircraft. That's not necessarily good at primary aviation training levels unless the flight configuration and the equipment is set up so similarly that there will be potentially a reduction in the chance of negative transfer. But there's other questions there. That's not the complete topic. There's also risk with that as well, in my opinion. So here we are. This is one example. I would say not ideal to be switching back and forth between electric and traditional piston engines. But if we had an electric aircraft that could use that had a 2 hour duration, there are several of our flight courses, which all or nearly all, practically all of the flight lessons could be done using an electric flight if it had at least a 2 hour duration. So that's something to think about. And that also requires evaluation of our curriculum. It also requires that the battery durations that we know today are lengthened, extended in duration. And then we need infrastructure at airports. So we need enough airports around the region to allow for a diversion, to allow for recharging during a cross-country flight, perhaps. So, we need roughly, and this also is a research topic. Maybe there's already work being done, but we need aircraft roughly 50 to 75 miles. No, not probably not to exceed 75 miles, that have a charging station or two available for electric aircraft. So again, more research is needed there about what's the ideal placement of charging stations at airports. So I will put that last caveat on there. We apply the so what and who cares. The so what and who cares is, we are currently, and I started with this context, using a lot of avgas to train graduates who go on to fly in the industry. And as these, Alaska Airlines, Frontier, Delta, Air Canada, United, American, Southwest. Obviously, I did not include all the carriers, but I'm not trying to omit any of them. They are hiring graduates. They are hiring graduates and people who have spent a lot of time, energy, and money getting their pilot certificates. So if there's a possibility of doing that less cost to the individual, and in some cases we know there are air carriers who have sponsored programs who are providing training to people who will directly enter the flight deck. That those reduction in costs potentially are a good thing, and that would be something that's worthy of pursuit. So what do we need to do? Ideally, we need a certified electric aircraft. That would be a good thing. So we know that the Velis Electro it's a experimental light sport aircraft. It does have some exemptions to allow for training currently, which has been helpful. But we need a Part 23 certified electric aircraft for training. That would be a good one. Airport infrastructure. So we need some additional time and attention focused on airport design, planning, charging infrastructure. Is this sort of baked into a ramp space? Is this, at the edge of an airport where it's not going to interact or cause any flow or taxiing challenges at an airfield? That could include ramp redesigns. There's also airport rescue firefighting considerations with the idea of battery fires. That's a valid question. I am not an expert in this particular topic, but I will say that sometimes people get fixated on that. But in reality, that airport rescue firefighting are also already training for other risks in and around an airport. So the question is, what are new training that they need or new equipment that they need to address this new power supply? Regulations, training requirements can always use some review. And I'm not in this day and age of, it seems like things are changing rapidly. I'm not necessarily saying that we should, change regulations quickly to facilitate this. I think they should be studied and they should be known and understood. The exemption, there's some recent exemptions I mentioned with the Pipistrel Velis Electro. That's helped with adoption in some cases. And there's quite a bit of research yet to be done. And I mentioned research, there's some airport infrastructure research. Maybe it's already being done or it needs to be done. Certainly UND can be partners in that if there's desire. Hot and cold weather performance. We know that temperature affects battery performance. So that is something that we would want to know in the real world, right? Labs are one thing, but real world testing is another. Charge and discharge cycles. We have a lot of engineers who have evaluated this in a sort of a lab environment. But again, we operate these aircraft in the ambient climate. So we, have a different experience than potentially a lab. So we want to know what that is. There's some human factors questions. One of them is range anxiety. So if, dissimilar to a single engine trainer, which might have anywhere from a 3 to 5 hour duration of flight time, what if you only have an hour and a half of flight time? Do you change your flight training? Do you have a change in human behavior, which changes our risk profile? So there's some questions there. Then finally, do we need to change how we interact with the aircraft itself? How do we pre-flight? How do we, do our run up? Where do we do our run up? Does ATC need a different set of operating procedures now that we are operating differently with electric aircraft? And then the biggest one, battery technology needs to improve. We need to understand that we need some 2 hour plus duration aircraft that are entering the market. So here's some goals. I'll kind of just present the screen here. If we can get to a goal where we have zero fuel burn per student with an electric aircraft, that's a good thing, I would say. We understand that that doesn't mean zero carbon emissions over the total life cycle of the battery. Completely understand that. Very valid point. But on a case-by-case basis, if we're not adding more fuel burn, generally that I think is a good thing. Reduced hourly cost to future aviators. Again, that's a good thing for everybody. So that helps with not carrying as high of a debt burden as you're entering the industry. And then, reduce our carbon footprint and use of leaded fuel, and reducing our leaded emissions into the environment is usually a good thing. So kind of went relatively quickly through part one. This publication, Technical and Regulatory Factors of Adopting Electric Training Aircraft in a Collegiate Aviation Setting, is available if you do a scholar.google.com. If you search for this title of the article, you will find this, and it is free to download. And there's quite a bit of background information in there to consider if this is the first time you're engaging in this topic. With that, I will say a pause and open it up to questions. Jackson, do you have any individuals who have offered questions? And I will get a drink of coffee while you do that.
Yep. I see a question here from Nathan Williams, who is asking, are you tracking your ground time? What is the average time an aircraft spends on the ground between flights?
Yes, this is a great question. As a part of this data set, we did not look at ground time. We have this data. So the short answer is, do we have ground time? Yes, we can get ground time. At one point, I knew what the average ground time was at KGFK. I don't want to misquote that. So I don't want to give you a wrong impression of what ground time is. So there is this open question of, well, the idea of logging flight time versus like what's the billable time on the aircraft. Some of this is a little bit of a different question when we look at, we know that logging of flight time, when an aircraft moves under its own power for the purpose of flight, is that definition of logging flight time. Maybe I don't know if that really needs to change from an FAA definition. If an aircraft is taxiing and you're intending to fly, but the engine is not running, or for example, the prop is not turning because you've stopped briefly during your taxi, I don't personally see why that would change how you would log your total flight time, because we stop with our single engine piston driven aircraft regularly. It's just that we're still burning fuel when we stop. In an electric aircraft, when you stop, there's a substantial reduction in energy consumption compared to alternatives. So my opinion would be, based on the regulation, that your flight time would not necessarily be changed. The question then is there a change in how that is billed, or is basically the flight time, the idea of Hobbs versus tack time, is that reevaluated with electric aircraft? And I think that might be a question to look into about billing and maintenance and that sort of thing. So I think that's a valid question. But there is some ground time, certainly, that could be a factor. But as far as how it would go in a person's logbook, unless the FAA comes out and has an interpretation, which I don't know why they would, um, I would see that there wouldn't be any change.
There is a follow-up here.
Okay.
And he says, what I'm getting at is charging restrictions. If an
Okay.
aircraft can go 1.5 plus reserves in the air, that's fine. But if it takes 3 plus hours on the ground to charge, that would be an issue,
Yep.
especially with an operation like UND, which has invested significant amounts into lowering its ground turnaround time, full line staff, dispatch, etc.
Sure. Yeah, I think that is a question. So we looked at it from sort of the first pass analysis of adopting this question. I don't know that 3 hours is the target. We would know that 3 hours for a fleet of 70 to 90 aircraft is not feasible for our operation today. But you have to start your analysis and technology adoption somewhere. And so one of the questions are, if it was a 20 to 30 minute turn, if you go watch our ramp on any given day, the aircraft do, once they park to once they take off again or start taxiing again, is not instantaneous. There is a fair amount of time where the aircraft is sitting stationary in chocks. So that's the question about, could this be done differently and still safely and meet the operational needs? These are great questions.
Nick, one thing just to jump in with, and by the way, thanks for you beat me to it and addressing a Hobbs versus tack time, just with the fundamental difference of, like an electric aircraft turning off basically when it's not moving. But anyone that wants to know more information about like charging rate, charging speeds, capabilities there, feel free to follow up with me afterwards.
Mhm.
It's an evolving field, but the quick answer that I'll give is that most chargers are designed to be at a C rate of 2C, which means a 30-minute turnaround time on the
Okay.
ground. Anything above that, thermal management becomes a big problem, but it's being done. So, anyways, just a quick plug there.
Yep. Great addition by Joe. So thanks, Joe.
Thanks, Nick.
Looking at time, maybe we'll do one more question. Is that okay? And then we'll move on to the next section.
That was it for questions.
Okay, great. These are good questions, and I'm glad that people are asking them because these are the same questions we're all trying to answer as well. So thank you for the individual who asked that question. Great one. Great question. Okay, so I'm intentionally changing the background for this next slide deck, and the reason is it's a different publication. It's actually related to a publication. It's not the exact publication, but it is the same data set. And so this next topic is something I co-presented with my colleague, Dr. Andrew Leonard, at the World Aviation Training Summit back in, I believe it was May of 2024. So the topic is assessing stakeholder opinions in the shift to electric-powered aircraft. And so we have some data from humans in this study, which is helpful. So let's come back to this idea of electric aircraft and why do we care? Why should we care? So we have this idea of environmental impact. 70% of lead emissions come from piston engine emissions as of 2017. So and this, of course, will vary with the amount of flight hours that the aircraft are flying. We also know that it's very expensive to fly. It's very expensive to do flight training. And so our estimation of flight fees, tuition, room and board is 180,000. And UND is actually, believe it or not, we try very carefully to manage student costs as a public institution. And so we are certainly not the highest at all in that particular cost, but flight fees and flight training costs are a factor. So, here we are, leaded avgas is a big source of those lead emissions. And, if you look at the total amount of flying that's done and what's the total amount of lead that we produce into the environment with 100 low lead, that's a concern. And we also have this estimation. There is an estimation done in a different study about how many people live within a half a kilometer, so 500 meters, which is, what is it? I don't know how that, 500 meters, everyone kind of understands what that means from a distance, but a half kilometer. And they looked at that's, 5 million people who are within the airport environment. And there's been quite a few studies that have come out and suggested that there is higher blood level concentration of people who live in a closer proximity to airports, and that may have an impact on them, which is subject to further study. So my colleague and I looked at these questions about not necessarily about lead and blood levels, blood lead levels, but the idea of, what are questions on, both the economics and attitudes related to electric flight. And one of the factors that we looked at is how important is removing lead from the environment on your decision matrix. So let's take a look and a little bit more context before we go into the study itself. I just grabbed these yesterday, and I thought this was fascinating to look at. So we think about, when you're talking about attitudes, we really have to look at our collective attitudes, our entire community as it's changing with the adoption of electric vehicles, whether they're ground-based or otherwise, right? So the chart on the left is from the IEA.org. So new electric car sales were exceeding 15 million in 2024, and the majority of those are sold in China. So that is an interesting data point. But of course, you can see that the US electric vehicle sales are increasing as well. And then I looked at a graph, and this is Europe, but we also can see that Norway, so I bring this up for a specific reason. Norway leads the pack with 91% of vehicle registrations being electric cars. And if you are aware of this topic of cold temperatures and battery operation, you go, there's no way electric aircraft could fly in cold climates. It's not possible. Well, we want to know this question officially, but it seems like the Norwegians are embracing electric cars in Norway. And we still have the open question about current battery technology and the impact of temperature on performance and what that means for an operation. So, but I like to show this graph. It's kind of an interesting visualization about the adoption of electric vehicles. So kind of useful information. All right, so we think about, within you have this background context, and we've mentioned weight a bit. So batteries are heavy. We know that. The battery technology is evolving. So it's actually been evolving quite rapidly in the last 10 years. And we know there are some questions on certification. We need an aircraft that's Part 23 certified aircraft, which can help with being available for various training programs, whether it's Part 61 or Part 91, and then we know that there's some airport infrastructure needs as we adopt. But what we don't fully know is all the attitudes that we carry with us with relation to our desire to change to electric aircraft. So that's what we looked at this particular study. So our sustainability survey, who responded to this, we in fact had 780 respondents in the survey after looking at valid responses. And the majority of them were students in flight training. So we disseminated this locally, but we also disseminated it in other channels. And about almost 2/3 of them were UND collegiate aviation students. We had about 1 in 5 were flight training administration or staff or CFIs. A small percentage were faculty, We had external aviation industry members were about a little over 4%, and then alumni or others were about 7%. So that's kind of a visualization about who responded in this data set. And then you wonder, okay, well, what's their demographic group? So we also looked at demographic group as a question. So Gen Z, of course, since there is predominantly students, then we have millennials, slightly less representation. Then we have the Gen X, the baby boomer range, and then people who did not respond to the question. So that's how that makeup looks. And then finally, certificate level. We had roughly equal amounts of commercial and private pilot holders or certificate holders. Then we had some ATPs in there in the green, and then some student pilot certificate holders, and then some rec and sport pilots, and a few that did not have certs. So this is a graph. I'm going to spend some time. Now that we know about who responded to this survey, I want to mention, this graph is kind of interesting. General opinion on sustainability in the aviation industry. So on the x-axis, that's going across the bottom, the level of agreement to the question of is environmental sustainability important for the aviation industry? So on the left would mean strongly disagree. On the right would be strongly agree. And then in the middle is sort of in the, I'm not really sure, it's not important to me, I don't care, somewhere in there. If you look at a total amount of the respondents, the people who don't think environmental sustainability is only about 6%. So that's people who are below the 3.0 mark. I lumped that whole group together. It's only about 6% of that audience. The people that are above the neutral, so anywhere from, yeah, it's probably, pretty important, but and to the people who think it's really important, that is almost 90% of this population that we studied. Okay, so that's an important thing to consider. This is a piece of data that's helpful to understand. So then we also looked at this question. So if you wanted, so understanding that sustainability is important, most of us think it's important, but the same group was asked the question, what would it take you to switch to electric aircraft as a discount? So if you know that you're paying $100 an hour, we know it's more than that, but if you're paying $100 an hour, what sort of discount would you need in order to switch to an electric aircraft? Okay. And this is what all those individual plots are and their age. So we put their age and we put their expected discount that would have them switch from their current piston-driven aircraft to an electric aircraft. And you can see this all plotted out. So we've got a lot of students here in this black, right? So that's Gen Zs, and Gen Y is in red, Gen X is in green, and the baby boomer group there, we didn't have too many, but we had those in blue. The interesting trend is as we are older, we have more disposable income. We're not thinking about potentially like a student, thinking about student loans and paying those flight fees. This trend line actually starts to trend upwards. So the amount of discount that we would need to switch to electric aircraft actually reduces. So it peaks, meaning the discount, the need for a discount is greatest when we're seniors in college. So the point at which we've accumulated flight fee expenses or potentially student loan expenses, we're looking at I think it's over 30x%. It's actually higher than that. So we have 25, this is about 37 and a half. We're probably approaching 35% as a college senior because they're really focused on expenses. As we are older and we have more disposable income, that changes to closer to that 25% range, meaning if an electric aircraft was 25% cheaper, I would fly it. Okay, that's kind of what this data is telling us. So I'm going to move on for time because we have quite a bit left actually to talk about. We then looked at the combining this question. We wanted to combine the question and look at, okay, if you think removing lead is important or good for the environment, what does that also mean as far as your expected discount to switch to electric aircraft? In this case, so on the sort of the bottom side, we call it the x-axis here, If you think lead, removing lead is good for the environment, if you agree with that statement, that's on the right-hand side, strongly agree. It looks like the expected discount there is about 27-ish%, right? Quite a high number of responses. If you look on the left-hand side, the strongly disagree. So people who think that removing lead from aviation fuel is good for the environment, if they said disagree to that, there's only 7. They also expected a higher discount. This is looking like 47% before they'd be willing to switch to electric aircraft. That's an important question, but you also have to look at how many people are represented in each of those bars. To help even drive this point home further, I took a heat map. I created a heat map of this. So this kind of makes the question a little bit easier to understand, is where is the data focused? Where is the most amount of data concentrated? And so the discount required to change to electric aircraft and the importance of removing lead. Most people agree that removing lead is important for the environment. So that's where kind of this yellow focus is. And then in that focus, we're looking at around a 25 to maybe 20 to 25% discount is about what people think that's our hotspot. Or you call it a sweet spot for data. So this can help us understand, where do people's opinions lie generally? And I always find this sort of visualization really helpful, particularly for policymakers and maybe marketing data. If you think about this as a business opportunity, which it is, this is important to think about. I know we have just about 12 minutes available. I do want to touch upon some qualitative comments, because qualitative comments, I think some people like to hear. So rather than the quantitative, which we've discussed, we also have the qualitative, which are sort of the people's raw opinions. So I had a lot of data to look at. So we just looked at a subset of this. We do have in this sustainability question sort of different groups, and we see the quant piece of that. This is the qual piece. And I call this group row 39. There's an indifferent group. So row 39 is people who are sitting way back in the aircraft. They're kind of along for the ride, whatever, right? And the comment here is, I don't have any comments or concerns at the moment, but all this seems really interesting and I will look into it in the future. You know what that means. I'm not planning to do anything today. I don't mind being more environmentally friendly as long as it does not cause me to take an unnecessary risk. Okay, environmentally is fine, but don't make me do anything that I don't want to do. Okay, that's the row 39 group. This is the resistance to change group. Too much, too fast. Just no electric airplanes. That scares me. If something's not broken, don't fix it. I believe pilots should stick to what we know because change can cause problems. Electric airplanes are not going to happen anytime soon. As it stands, I can barely get a gas-powered aircraft. Electric airplanes, to me, mean longer turnover times and less flight slots. People are afraid of change. That's true and has been true since the beginning of time. So that is a thing, right? So that is a group of the population. There's another group of the population, and I have to admit, these are AI-generated images just to kind of give you an idea. This pilot has an extra hand, or it looks like their crew member is obscured. But I wanted to, the quotes are real. So these are real quotes from people. So in this case, the group is obligation and be a leader. The quotes in this group suggest, I think it's a necessity for the future of aviation. Making any move to sustainability is of great benefit to the aviation community and future world. I think we should do it as fast as we can. And then finally, it'll happen eventually. Better to bite the bullet and get it over with earlier. So this is an interesting group. They're going to help lead the change. They are going to be willing to take on and try new things, and they also feel an obligation to their community in some form or fashion. I believe there's one more group. This is a guilt and frustration group. This group is motivated by the fact that potentially what we're doing today is needs to be done faster, or maybe what we're doing today isn't as good as an alternate. So the quotes from this group included that we're not investing more in sustainable equipment already. So this person is frustrated that change is too slow. Next quote, I believe the aviation industry needs more environmentally sustainable options for flying, as I have seen many articles about public figures and their private jet usage. These articles put aviation in a bad light by talking about emissions in these aircraft. And then the other one we have is aviation is already seen as a not very environmentally friendly industry. So anything that can help the image of aviation's environmental impact helps. So this individual's quote is really thinking about the aviation industry and its perception in the broader community, which is it's an important motivation. So I share these because that quant data is nice and it makes nice photos. The qualitative data helps tell the story. And you can see where those data points come from based on these attitudes, which is really interesting. So we've talked about these barriers to adoption, weight and battery technology, certification, infrastructure, and we also touched upon the focus of this last presentation was on our attitudes. Our attitudes can be a barrier or a catalyst for adoption, and it really depends on how we adopt that. And so just kind of a final image here, we have our graduates and where do our graduates' opinions lie? And generally we think that we want to remove lead from the environment. And we also, wouldn't mind electric aircraft if there was enough of a discount. And we also think that environmental sustainability is important for the aviation industry. And one way to get there is electric aircraft. So these are sort of our future, and we should think about that when we're considering policies and support and research and all of these sort of things. If you want, there is a publication on this topic recently published with my colleagues, Dr. Andrew Leonard and Mr. Michael Lentz in the Transportation Research Record. So a subset of what we just presented without the qual is in the data set here. So with that said, I will actually pause for questions. We have a few minutes for questions. Happy to take them.
It doesn't look like we have any at this time. Oh, okay. Sorry. Just one came in.
Okay.
I was a bit late, but positing the study with regards to lead versus electric. What about transitioning to unleaded fuels? How would this impact the conversation?
Right. So this study was done without that question in mind. And I think, no, I take that back. We actually did include in the survey data. It's a separate study that is actually going to come out shortly. So it's actually it's not yet published, but we have questions.
Elisa, this is so bad. I'm sorry.
Oh, okay. So we have a question related to unleaded aviation fuel. There's more analysis that we can do because we do have a question on unleaded or survey data related to importance of unleaded aviation fuel. So that's a great question, and more analysis can be done. Does it is unleaded aviation fuel likely better for the environment? With respect to lead, I would assume so. I'm also not a chemist, so I don't know what goes into unleaded aviation fuel as an additives and the various other things compared to what's in leaded aviation fuel. But if you just look at the lead question, I would assume that people prefer unleaded aviation fuel over leaded fuel if we had an option. Great question.
And it looks like that was the last one.
Okay. From Joe. Joe, do you have questions?
Yeah, maybe I'll throw one out there. So a lot of this was just kind of like asking open-ended questions about like price point and attitudes. Maybe like one thought, and it's hard to maybe answer this now, given that there are a few electric aircraft flying out in the U.S. right now. But do you think that there's going to be future studies needed on just like the experience in flying in an electric aircraft and
Right.
how that may impact attitudes and things as well. And so like one thing I think about is, and I don't have any data to back this up, but I heard anecdotally that, flying in an electric aircraft is actually, it's better for CFIs in the sense that there's less noise, vibration, other things that would induce fatigue.
Yes.
Is that like an area of future research that you think needs to happen once
I would
these
love to do
aircraft?
that.
Yeah. Yeah.
I would love to do that. And I've heard similar things. And for the members of the webinar, and thank you, Joe, for the question, UND does not currently have an electric aircraft. I would love to have one for the purposes of research to answer the question that Joe has mentioned, to have people have the experience of flying an electric aircraft. And I have not yet flown an electric aircraft. If there is a private angel donor on this webinar, we would love to get some funding to do a cooperative study, potentially with MnDOT or the University of Minnesota and UND. That would be a great study to look at these questions. So whoever's listening to this, take note. Yeah, we would love to get some funding support to do something like that. Great question.
Yeah, that's a good plug there, Nick. Appreciate it.
I have to plug. It's an obligation.
We got one more that just popped up. I can read this one. So question, are some of these graphs and figures available either through the published documents listed here or somewhere else to reference?
So there are some of the documents are available in the publications. So yes, some of this are in the process of publication, and so I'll have to see with the publishers whether I can disseminate that. Sometimes there's some limitations on how things can be disseminated or not, but I am happy to make that available, that which is helpful to the community. So great question. Any other questions from the audience or Joe or Jackson? Okay.
Nothing from the audience, nothing from me.
Okay, great. Well, I appreciate having the opportunity to discuss with the MnDOT community, as well as hosted by the U of M, and also from audience members who represent not just MnDOT, but across the industry and with interests in general aviation and electric aircraft broadly. So this is not as was mentioned, I think, Joe, you may have mentioned this. I don't remember who exactly said it, but aircraft don't follow state boundaries and they don't follow international boundaries. So all of these questions impact everyone, and they are benefited by a common interest in investment and research and study. So thanks for the opportunity to discuss.
Yeah, thanks for the time, Nick. Really appreciate it and sharing your expertise and the quick plug in as well and taking this on short notice. So really appreciate it. I think Jackson, do you have any closing remarks regarding the survey or anything like that?
I do. Yeah, I'll echo Joe saying thank you, Nick. This was great. And my request to everybody that's in the audience here is I shared a link to our evaluation. Please, please, please take a minute if you can to fill that out. That truly does help us going forward with these. And then that does it.
Thank you very much.
Awesome.
All right.
Thanks,
Okay.
everyone. Appreciate it.
Thank you, everybody. Enjoy the rest of your day.